So in the previous session, we spoke about boost data idea to fruition, which you can check out on our YouTube channel 99X. But today's session is boost data business intelligence through log analysis. So brief introduction on Boost. Boost is a market leader in the Norway vehicle inspection sector, which 99X creates fully functional APIs for. And during this session, our speaker will show you how to take log analysis and turn it into a full-fledged business intelligence solution. And we'll go into detail and demystify the log archival pipeline and business intelligence with Power BI tactics. So a little introduction into our speaker today. Our speaker's name is Chandira Gunatilleke. He is a trainee software engineer at 99X and is currently working as a researcher in developing product analytics to solve problems faced by big data. So, Chandira, I will hand over the session to you.
Thanks, Chantal. So, hi everyone, I'm Chandira. I hope y'all can see my screen. So, today's session will be session number 2 in this series, Boost Data Business Intelligence through Log Analysis. So, to start off, I'll just run through the contents of today's webinar. So for the people who are joining for the first time and who did not join the first session, I'll give a brief summary of the project and the company this was implemented for. And next, I will run through the problem which we had and how we identify the requirements for the solution. And next, I will go over the log archival pipeline, which is a key component of the solution. Next, I will go over how we implemented and provided business intelligence to stakeholders using Power BI. And I'll be finishing off the webinar with describing how the lessons we learned and the ongoing improvements for the project. And we can wrap it up with a Q&A. So to start off, the project which we implemented the solution for is called BUS, like Chantal mentioned. So BUS is a Norwegian-based IT supplier which offers a software suite for the automotive industry. So they basically make software which is used in workshops and garages to inspect vehicles. So when you're talking about BUS, they have over 30 years experience in the industry. And when we're talking about statistics, over 1 million inspections are made each year using BUS software, which accounts for over 75% of all vehicle inspections made in Norway. Talk a little bit about the approach. So what they do is they bring in vehicles into workshops and they go through what you would call checkpoints, where workshop repairman would check different parts of a vehicle for defects, and they would enter that data into the BUS software. So over the span of 3 decades, BUS has collected this data on a lot of vehicles, and BUS approached 99X with the idea to create a solution that could predict a defect of a vehicle when the mileage and the a third party identifier is given to the software. So 99X in partnership with BUS created the API, the BUS data API, which is capable of instantly predicting defects related to all checkpoints associated with an inspection of a certain vehicle. So Netmal talked about the architecture of this solution in the previous lecture. So if you haven't seen it, please go and have a look after this session. So that is the basic summary of the project. And next up, what we're talking about today is the problem of what happens after any user uses this API. So the problem can be broken down into 2 parts. The first part is archiving this data. So when a request is sent to our API, we basically get get user feedback and data of what prediction was made. So that is logged into a resource called Azure App Insights, which is the default resource provided by Azure for Azure functions and other compute resources. So our problem was we were collecting a lot of data and basically a lot of telemetry data that we didn't really need. We just needed it for any like if we needed to troubleshoot it. So we were collecting and storing data that we didn't really have a need for. But there were certain aspects of this data that provide business value. For example, Bus lends this software out to different vendors. So it would be useful to know that this vendor made this request and they got this result back. So that is also part of the logs. And one issue we had was the default retention period for logs was 90 days. And this was the Asia default. So we could, of course, extend it, but that would cost a lot of money as we're going forward because we would be saving unnecessary amount of data that we use for troubleshooting, but would not actually give any business value back. And the last reason was because of this 90-day retention period, we were actually doing manual backups of just the data we need, and this was consuming time of our developers. So for this problem, the goal was to create a solution that automatically archives just the data we need, and we can keep it in a human readable format to be accessed by anyone. So the second problem was visualizing this data to the business stakeholders. So at the end of every sprint, what we usually do was we use the logs. We created some Python script to pass the logs, and then we created presentations and we presented it to the stakeholders. So this was all done manually, which was the most which was a huge pain point. And any uh, sort of trends or spikes in certain trends would only be notified to stakeholders at the end of each sprint, or it would take manual effort to notify the stakeholders. So this all cut down developer time, which could be spent for something else. So we got the idea to entirely automate the process and create a dashboard that could be accessed by business stakeholders, and they could actually go through the data themselves without any technical knowledge uh, to get the data they need to make business decisions. So this was the ultimate goal of the entire solution. So moving on to the next section, which is the log archival pipeline. So as I mentioned, this was a key part of the solution. So this addresses the first problem, which is archiving the data. So if you can see here, we are using an Azure function, which is a serverless compute resource from Azure to handle incoming requests to the API. So this is the Bus Data API. Basically, this was covered under the previous webinar. So from this Azure function, when requests are made to this Azure function, we get data and it's logged into the default App Insights resource. So because of some changes Azure made, it's actually now difficult to export this data. So what we did was we changed the App Insights resource into a separate resource called a Log Analytics Workspace. So to describe a Log Analytics Workspace is it's sort of a hub for several different where you can point several resources, and all the logs of each of those resources could then be analyzed in that workspace. So from that log analytics workspace, which this also had the retention period of 90 days. So from that log analytics workspace, we would then export data using an Azure Logic app. So an Azure Logic App is another type of serverless compute, but this uses a graphical user interface, so it's easier for non-technical people to create this. But the most important thing is Azure Logic Apps have connectors which connect to different software and different endpoints. So the reason for using a Logic App was they had a direct connector to the log analytics workspace. So we use the Logic App to export logs from a log analytics from the log analytics workspace on a periodical basis. So every 15 minutes, this Logic App would run a query and get just the data we need, and it would transform it into a format that we prepared for, and it would write that data into a blob storage container. So a blob storage container is basically, for those of you who don't know, is basically like a hard drive that's on the cloud. So basically like a Amazon S3 bucket user. So from that, uh, we use another Azure function to group and pass the data. So this, why this was needed, I will explain in the next slide. So just keep in mind that this is a intermediate step, and that Azure function would then transform the data and write it into a separate format into another container. So this would be the data flow of the logs once it is written into the log analytics workspace. So why do we need that additional compute layer in between the two blob storage containers? So because of the nature of the Python code, uh, and since it's easier to troubleshoot, the logs we get is similar to what you see on the top. So for example, all of this data is just for one request. So this was made, this is created in this way, so to make it easier for troubleshooting. So we can pinpoint to the millisecond what went wrong if something did went wrong. So because of this, the amount of data that we collect was huge, and we needed a lot of compute to pass this logs. So basically, if I go back, the log analytics workspace uses a query language called Custo. So that did not have the ability to pass logs and group logs in the way we wanted. So what we did was we used that additional layer of compute to run a Python script using pandas to group the data and then bring it into the format we need, which is displayed below. So all of this data is basically for the first request. So we had a lot of telemetry data that we did not need after 90 days. So basically we did not need it for anything other than troubleshooting. So we got rid of that. We passed the logs and we got just the data that adds business value. So there were several ways we could do that. First, of course, is the one I mentioned already, which was using the inbuilt query language in the Azure Log Analytics workspace, but it did not have the ability to group logs. So that was a drawback, so that we couldn't use. The second way was to directly import it into Power BI using direct query and then transform that data. But that is also not feasible, and I'll be explaining why in future slides. And the third way was to run a Python script inside Power BI to basically do the exact same thing we are doing with Azure Functions. So this could not be achieved because the parsing and the grouping that we need is too compute heavy to run as a script inside Power BI. And to add to that, we wanted to store the data in an open format, and we wanted to decouple it from the dashboarding tool. And so the final data format we needed it to be in a separate container outside of the dashboarding tool. So if we, however, did manage to run this as a Python script within Power BI, that would be still inside of Power BI, and we would not have access to it outside of that. So we did not want to go with that route either. So why did we choose an Asia function as the compute resource and not like a logic app as before? So one, it's cost efficient because Asia functions require more development and more maintenance. It's cheaper to run an Asia function than a logic app. The second thing was it, it it can run code on an as needed basis. So basically, this if I go back to the previous slide, this Asia function is triggered whenever a file is written into this blob storage container. So uh, because of this architecture, we can cut down costs in a huge way. So basically, if you don't have logs, the logic cap will not write anything to the blob storage container, which would then mean the rest of the pipeline does not get executed. So we would not incur charges for running the Azure function because there is no file being written to the container. So we only get a file if there are logs in the previous 15-minute interval. So that was the second reason. The third reason was uh, since we were already using Python and pandas to manually parse the logs, we could use the same scripts with some slight modifications uh, to parse the logs within the Azure function as well. So this cut down development time of this solution. Next is the dashboarding tool. So we researched different options for the dashboarding tools. And if you remember, when I was going through the content, we selected Power BI. The reason we selected Power BI was we had several reasons when compared to other options like Kibana from Elasticsearch and Tableau. So the main and most important reason was Power BI is part of the Microsoft ecosystem. And since the entire Boost project is run on Azure, this was crucial because then every part of this solution would be under the Azure and Microsoft ecosystem. The second thing was Azure AD integration. So the stakeholders needed this data to be secure, and they needed this data to be only accessible by certain business stakeholders within the company. And we were already using Azure AD for other Boost products, and one of the requirements was to provide a security layer using Azure AD, and building that into something like Kibana or Tableau, where we would have to host it on a web app and then create a separate layer on top of that for the Azure AD integration would like it would take a lot of time. So the third option was that because this would cut down development time in almost half. So the third thing was Power BI is relatively cheap. So with Tableau and Kibana, uh, especially Tableau, the pricing model is totally different. So Tableau has this built-in AI and machine learning functionality. So even if you don't use those features, you're being charged for it. And they have separate accounts, basically a more expensive option for the people who are creating the dashboards and the reports, and a more cheaper option for people who are just viewing the dashboards and the reports. The cheapest option, which is the viewer account, was still more expensive than the Power BI Pro account. So for Power BI, they charge a flat rate for all viewers and uh, the people who create the dashboards themselves. So it was just a flat rate. And Kibana, of course, you could self-host it on a web app, but when comparing the amount of users that this needed to be handed out to, Kibana and Power BI would cost around the same. But Power BI, of course, we could integrate the solution much faster. Tableau, of course, was out of the question because for what we are using, it was not the right tool and it was too expensive, and it did not, as I mentioned, it isn't part of the Microsoft ecosystem, and it didn't have Asia AD. So those were the reasons we went with Power BI as the dashboarding tool. So next, business intelligence with Power BI. So this is the second part of the solution. So this addresses the second problem, which was the pain of visualizing data to the business stakeholders. So if you remember, we wanted to decouple the data from the dashboarding tool. So in the future, let's say, for example, you want to scale this out to like 100 or 200 people, and then the tool of choice would change. So then Power BI would no longer be the most cost efficient way to do this. Then it would probably be best to use Kibana and set it up as a separate web app with our own security integration. So we anticipated that these requirements might change. So we wanted to decouple the data from the dashboarding tool. So what Power BI does is it basically runs a query, and it gets data directly from a couple of containers of the blob storage in the Asia environment, and it builds a data set of its own. Uh, and if I move into the Power BI architecture section, so what it does is this is called a ETL pipeline. So what Power BI does is it combines data from several locations. For this example, though, it was just blob containers. So it gets that data from there, and there are several steps within Power BI where it takes the data, converts it into the Power BI compatible format, and it models the data according to our specification. So basically, how you would design a SQL database, the same thing you can model the data in the same way within Power BI as well. So because of that modeling and because of how Power BI transforms that data, it adds that data into a Power BI data set. So in a efficient manner that it can quickly retrieve data and quickly load the visualization. So uh, to recap, Power BI goes to the blob storage container, gets the data, transforms it, and creates a data set of its own. So this data set is hosted in the Power BI web service. So it has its own storage, and it has its own memory and compute. So any dashboard or report is built on top of this data set. So that's basically the Power BI architecture. One more thing, let's say you have data that you don't want to store on Microsoft servers, basically Power BI servers, and you want it to be hosted on your own servers, but you still want the functionality of Power BI. So in our example, because it wasn't like because we didn't have any GDPR issues, we could store the data on their own servers, and then we could directly access it through the Power BI web service. But you also have the option of hosting the data set on your own servers, and through an API gateway, access the reports and dashboards. So you're just paying for the visualizations. The data is all loaded onto your own servers. So that is the Power BI architecture. So next, I think I'll show you a demo. So this is basically a demo app I created out of what we have already provided to the business stakeholder. So for example, this is the summary of all the requests made to the API. This is all. So this is currently not connected to anything, but in the actual app, it gets updated with live data. So I'm just using this to show how powerful Power BI is and what sort of analysis you could do without any technical knowledge at all. So this is what the end users, the business stakeholders see, and they without our input, they can basically run through scenarios and get the data they want. So, for example, imagine you want to know, we want to filter down the data to requests that came in from February, March, and April. So just like that, with 3 taps, you can filter down the data to just the section you want. And from there, you can see the average time taken to deliver prediction, the number of predictions returned, and the total request and statistics like that. So if you see here, the graph here shows the release dates of the solution as well. So you can, in addition to what you're getting from the core data set, you can add details on top of that as well. So basically, the possibilities are endless. So another thing I want to show is the filtering capability of Power BI. So for example, this has all the data. Again, this is just dummy data. This has all the data, let's say in the last 6 months. So from here, imagine the stakeholder wanted to know what request did not return any predictions or that returned fewer than 5 predictions. So what they could do is go to filters uh, and select this is less than condition and put any number they want. I'm going to put 5 and then hit apply. That would filter down the entire set of data to just the request that had the number of predictions returned, which were less than 5. So you can combine multiple conditions and basically do any kind of analysis you would want in here. So, and there are uh, built-in visualizations you could use. So all of these visualizations were provided by Microsoft and or as a plugin within their store. So a lot of things could be built really quickly without any sort of development. You basically have to model the data and point it at the visualizations, and it would sort of create this. So that was just a small demo. So what did we learn from this, and what are the ongoing improvements of this solution? So Power BI has two I could say dashboarding solutions. One is called reports and one is called dashboards, Power BI dashboards. So what you just saw was a Power BI report. Even though it looks like a dashboard, it's called a Power BI report. So when we were first approaching the solution, we wanted to provide live data. Like as soon as you get the request into the API, we wanted it to be visualized in the dashboarding tool and ready for analysis. So Power BI, we utilized a feature of Power BI called push datasets, which is basically an API endpoint where you would send out data and it would uh, update live the database which Power BI has. So a drawback, we initially used this, and a drawback of this solution was because of the way it is structured, and I think it's still in beta right now. So because of that, the features that were available for live data sets was really limited. So the visualizations we needed, we couldn't build because this was more geared towards like IoT devices and sensor data, which you need access to in real time, and which you didn't really need to do complex calculations on. So this was more geared towards that. So we initially tried that, but sadly we couldn't get the same information we needed So we switched to a Power BI report. So Power BI reports are basically meant to be shared within the organization, and they also have a data set. But the drawback of this is they have a limited refresh window. So the Power BI data set that is backing the Power BI report is not live updating. So it would update on a certain number of times during the day, and it would show the visuals. It would update the visuals depending on when it was last updated. So we talked with the stakeholders and we realized that the real time uh, real time solution was not did not offer what we needed, and the trade-off was not worthy. So we went back to the Power BI report solution, which we can we can get data, we can update data every hour or so, but we can get a lot more information that is actually useful for business stakeholders. So that was a really important thing we learned. And as for ongoing improvements, we are trying to integrate alerts and status of resources to the dashboard. So even for, I think this is not just useful for business stakeholders when we are troubleshooting. It's easier to use this dashboard instead of writing custom code to analyze these specific scenarios. So we were thinking of integrating alerts and health status of resources to the dashboard as well. And also we are, I think Nitmal also mentioned this, we are currently working on a separate model to address some drawbacks we are currently having. So depending on that, we are also planning on adding some other statistics needed by business stakeholders as well. So I think that's all from me. I guess we should go to the Q&A. Shanta?
Yeah. Hello. If you have any questions, please drop them in the chat, or you can feel free to unmute yourselves and ask them. I think we have one question already. Someone wanted to know whether these are documented to look into later on. Is there any documentation on your research that's available to the public?
We have documented it, but I don't think it's available to the public as of now. I think the basic architecture is what you would need, and I guess we are uploading this to YouTube, so anyone who is interested could go and look through that and basically implement this on their own. The finer details, like the code we use to parse logs, is dependent on the project and the requirements. So I don't think it would be relevant to any outsider.
We have one more question. Was there any risk or concern with using Asia functions due to the timeout?
No. So basically, was this for the compute for parsing logs or the Boost Data API itself? So if we are talking about the Boost Data API, we have it's on a premium plan, and it basically has one worker up and running at all times. So there we don't have that issue. For the compute resource, it's using a consumption plan. So as the file is being written, the Asia function will be triggered, and on a as needed basis, it will go through with the compute. So we tried putting like files with a lot of logs on it, and even then the function could manage to pass the logs in an acceptable time. So when we are breaking it down into like 15-minute intervals, the number of logs that it needs to process at one time is really low. So there isn't a huge risk of the function not working as intended.
Thank you. Are there any more questions? We also have Netmal, who conducted the previous session, who can also answer some questions as well. So just let us know if there are any more. You can unmute yourself. We can give it 1 minute. seems like that's all the questions for now. But yeah, feel free once we drop this on YouTube, you can also use the chat and ask any questions you have later. Yeah, so I think that concludes the Q&A. So looks like we've come to the end of our session. First of all, I want to say thank you to our speaker, Chandira, for agreeing to conduct this session. You've given us a lot of insight into business intelligence through blog analysis. And also to our audience for attending today's session. So thank you a lot and good evening. And also please check our social media and follow us on all social media accounts at 99x. And just tune in for any sessions that we have in the future. Thank you. Good evening.
Bye, everyone.